All right, here we go. What if we have the same set of curves, like y equals x squared, but instead of rotating about the x-axis, we're going to actually rotate it about the y. It's going to make a different shape. And again, we can pretty quickly graph y equals x and y equals x squared. And we have our area here. Now we're going to rotate that region around the y. All right? Well, now your integration becomes dy. But it's still area of y now. You're still going to do cross-sectional areas, but you're going to take those areas this way with respect to the y-axis. And again, since this is a simple function, do we agree this is 0, 1, and 1? So our integral goes from 0 to 1. It is still a ring. All right? It is still a ring in that
Is the volume the same?
It is in this case compared to the x dimension because of the way it's shaped. But we're going to do another one here where Ri is the inside, Ro is the outside. Problem here is you can't say y equals x squared. You can't use y. We have to solve these for x. Well, x equals y. Well, I take this. If I solve for x, do you guys agree I get plus or minus the square root of y?
Yeah.
Well, why do I ignore the negative?
Because you're only dealing with the positive.
I'm in the first quadrant. So I have Ro, the outside radius is square root of y. I have Ri as the inside radius is y. I know that the area of a ring, in this case, is pi Ro squared minus pi Ri squared. And now I just simply substitute in those values of Ro and Ri. And now it becomes plug and chug time. Take the square, and then finally, it's just doing the antiderivative, or the integral itself, evaluating it from 0 to 1. In this case, I get pi over 6. Now, again, this method works whether you're on the y-axis or not. You can do it about another parallel line to the y-axis, like x equals -1, another undefined slope situation. But in this case, it's the same two curves, but now we're going to rotate across x equals -1. And do we agree my y value still goes 0 to 1?
So that the ring will be bigger because the radius that it...
Yep, it'll be hollow and the radius will be bigger. It will. It's still 0 to 1 on the y-axis, ay dy. It's still a ring, but this time the inside radius is here, the outside radius is there. It's simply adding the 1. And pretty quickly here you're going to catch a pattern with this, but I recommend you make the picture every time until you really understand where the
Even if it's not a good picture?
Even if it's not the greatest picture. Yep. Again, you know it's Ro squared, pi Ro squared minus pi Ri squared. It's a ring. This time it gets a little uglier, right?
Yep.
You end up having to plug in binomials, or two-term things, all right?
Yeah, but it gets rid of the square root, so that's not that bad.
Yeah, well, no, it doesn't.
Or no, it doesn't.
The middle term's going to carry the square root.
Yeah.
So when you expand those and distribute the negative to all three terms, you end up with 6 terms, all right? And then I combine like terms, all right? The 1's cancel, y minus 2y is -y. I write in ascending power. A lot of times you'll see people put the radical first. I don't.
But it goes on either end, not...
It doesn't matter. Yeah, well, the truth is, you really can't be wrong. But again, from here, I think you guys got it, all right? Antiderivative, all right? Now I realize this is y to the half. Add 1 is 3/2, divide by 3/2. And again, I don't get cute and try to simplify here, all right? And then I do my fractions. I make sure that 0 actually makes all the terms 0. And this time, the volume is pi over 2. All right?
Makes sense.
And these are volumes revolved around the y-axis. All right?
So are we going to get into shapes that are like, you know, they're a certain way on this axis, so you...
Yep, we can do both. We'll get there. You can turn that off.
What about